Alright, we're coming back to a new section. This is 2.3, and we're going to be talking about the attributes of absolute value functions. So just like a little recap, where's my cursor? There it is. In 2.1, we learned how to solve absolute value equations. 2.2, we learned how to solve absolute value inequalities. And this looks like this. 2.3, and which is today. We're talking about attributes. And I want to talk about the word attributes again. In the first unit, I told you that attributes are talking about like describing something. Like for example, if I would ask you to describe Newman Smith High School, you would say it is part of CFB ISD, one of 4 high schools in CFB. You could say that it is on Josie Lane. All of these things that I'm describing about Newman Smith High School, these are all true. They're not opinionated. Not opinions. They're facts. As in, when I go to like my absolute value function, we're going to be talking about the facts. So students will be able to describe key attributes of absolute value functions. And what if I told you, where's my picture? There it is. Okay, what if I told you that absolute value functions, when you graph it on Desmos, which I will do, sorry, y equals absolute value of x. So let's take a look on how that will appear to do so. Why is my margin so weird? Let me try refreshing this. Y equals absolute value of x. Okay, there we go. Alright, so yeah, what we notice is that it has a V shape. And the V shape is very natural for us to know because we know that an absolute value of -2, if the absolute value of -2 is 2. So that's why it's plotted like this. So really, it's symmetrical because no matter my x value, if it's positive or negative, it'll have the same y value, as in -4 and +4 both have 4 as your y. Same thing with like -10. -10 would have 10 as its y, if I can get there. Good. And I know that the absolute value of +10 is 10. So it makes sense that it would be a V shape because think of it as like 2 linear lines. Y equals x, y equals -x. So you see like these 2 lines, like they're just pretty much just taking just the positive y value versions of both of these graphs. Because as you know from our previous sections, we cannot have we cannot have an absolute value of a number and we cannot have it turn into a negative number. There's no way. This is a no solution. That's why my graph in Desmos does not have any y negative values because it's impossible for you to have an answer that would be negative if I take an absolute value of it. So let's start by first drawing this graph, which I know that it crosses like 1, the absolute value of 1 is 1, the absolute value of 2 is 2. So I would just continue to set that trend like so. But what about the negative version? I just stated that your y values cannot be negative in an absolute value function for now. So -2, the absolute value of -2, or -2 is 2 steps away from 0. So if you put in 2, you would get +2, and so on and so on. So that graph looks like so. So how does that affect our domain and our range and all of that stuff? These are all attributes, as in these are all describing our parent function, which is this. Know that this is called parent function because it's the most basic. I'll write it in the bottom. As in the parent function for linear is y equals x, and then y equals x squared is the quadratic parent function. That's just like a name for like the most basic version of that type of graph. So for the domain, if I draw like my little like arrowheads, I can say that, oh, my line goes like this and goes like this eventually, forever and ever. So really it goes up because they're both going diagonally up, and one side's going to the left and one side's going to the right, and no arrowhead is facing the direction going downwards. So I have no range going downwards. My domain, I know that if I'm going left and right infinitively, forever and ever, that means that my domain is going to be infinity, negative infinity to infinity. As in, I'm touching all my values. As in, I could get any x value if I want to. Know that domain and range, we're talking about possible values. But what about my range? My range, I know that I can't have any negative values. So the way that we write that is, what is my smallest value for my range then? Is it 1? No, because my 1 isn't my lowest value. My lowest value is actually 0. And you see how this line is dotted? Or not dotted, sorry. It's solid. So I would write a bracket with a 0. And I drew also that my diagonals are facing upwards, as in I'm going to infinity upwards. And that makes sense too, because I can have a y value that would be like 10,000 or a million if my x's were a million as well, or negative million. These show my possible y values that I can have from 0 to infinity, as in 0 and every other possible positive number. The x-intercepts, we know that the x-intercept, it touches here, right? So that would be x equals 0. And my y also touches here, which is y equals 0. So there's only one intercept in our parent function. Our vertex is the word vertex. Think of vertex like let's say for example I have this plane, right? And you fold a piece of paper and you make a paper plane that looks like this. And then, like your hand is like right here, right? Yeah, whatever. Your hand is like right here. This is like a paper plane, but if I draw it from the side, it would look like this, right? And there would be like a crease right here or something, whatever. That crease right there is like the line of symmetry, right? But my vertex would be like right here, where the graph can be like, well, the This symmetrical line would be like in the middle of this, right? But this right here, this would be like my true like folding point, as in like it would be like where I would start the graph from going one way to the other. So if my vertex is what I start for both of my sides for it to be like symmetrical, isn't that, which I will write in blue, so I will circle this like this teal color, isn't that also right here too? As in this, if I go to the left, which I would draw in a different color, if I go to the left, I would have to start from here and then go leftward, right? I can't start here to have only one direction. But if I start from the middle again and I go rightwards, it has the same direction. It shows that it's symmetrical from this point, as in this shows like this is the point where opposite forces are being applied to this, and it's even, and it's also like purely opposite, and like it's going from both points. It's like going from like a different direction from the same point. It's like the turn. So this vertex, that coordinate, we write it as an ordered pair. I guess I should write it in the teal color. The ordered pair is 0, 0. And I'll write it like this, 0, 0. So that you know that this is a ordered pair. This is not an inequality. This is an ordered pair. So know that your vertex is very similar to your axis of symmetry. Because your axis of symmetry, if we're talking about this point being like the split between the left side and the right side, doesn't that mean that my axis of symmetry is going to include my vertex? Like here? How do I write this line? And the way that I write this line, once again, is if I have like, I don't want to use this color again. If I have like, for example, this point right here, the coordinate of this point is 0, -4. And this point right here is like 0, 7. The two things that these 2 points have in common is that x, they are both equal to 0. As in this point right here would also have x equals 0. This would be like x equals 0. This point also has x equals 0. So the way that we write this line that goes up and down is actually x is equal to 0. Because all of my points are going to have x equals 0 for their coordinate in that line. So that's pretty much just the attributes of the parent function. So we can, that's pretty simple, right? Like that's algebra 1, like we're just looking at a different graph. But what if I told you that we can change things around? That we can move it to the left, we can move it to the right, up, down. We can make it skinnier or fatter, or we can make it like the slope bigger. There's like ways that we can make our absolute value different. And I want you to graph these and tell me the new domain, range, intercepts, and symmetry, just like before. Notice that there's no vertex because we're going to be talking about that more in the future. So I'm going to give you guys 5 seconds to pause the video to try to do by yourself. 5, 4, 3, 2, 1. And welcome back if you tried it or if you paused it. And if you didn't, sure, these are your notes. These are for you to practice and apply yourself. So I know that my function is this right here. X equals, or y is equal to x minus 4, and then take the absolute value of that. So look what happened to my graph. If I write the regular parent function, from the purple to the red, it went over 1, 2, 3, 4 units. That's a coincidence because isn't what different in my equation is x minus 4? Yeah, it is. And if I take a look at this right here, I can see that All I did was move it to the left and right. But we also know that our domain already had all real numbers. As it does, moving it to the left and moving it to the right, or moving it none, does it affect our domain if it really just touches all real numbers eventually? No. So really, our domain is still going to be negative infinity to infinity. Because it doesn't matter if I move it left or right, it's going to touch all numbers eventually. It just doesn't start the same place, but it could. As in this, we're talking about the possible x values. What about the range, the y value? Like, I didn't move my graph up or down, so did it really affect my vertical possibilities? No, it didn't. So the lowest point I can have right here is 0 as y, as in it's on the x-axis, and the possible y values are endless, which is written as infinity. But what's different now is my intercepts, because my intercepts, I'm not at 0, 0 anymore. My vertex isn't at 0, 0. It's at 4, 0, which is right here. So let's get rid of that one. So the intercepts, good thing about Desmos is that it shows your intercepts right here. Which your y-axis, because this is the up and down line is your y-axis, is y-intercept is 0, 4, and this is an ordered pair. And your x-intercept is 4, 0. So what did you notice about these two graphs? Or these 2 points, sorry. These 2 points, they switched values. As in, like, your 4 became your 0, and your 0 became your 4. As in, your x became your y became your x. That's not gonna always happen, but it's pretty nice that it does happen like that, because all we did was move it from the left to the, from the, like, the original, the origin to 4 units to the right. And that's really what happened, because if you go 4 units to the left when you want to go to 0, don't you also have to go 4 units up for it to make sense? Yeah. So the line of symmetry, we look at where it could fold, or we can cut this graph in half. Where would that crease be? And wouldn't that, like, crease be, like, along this line right here? Yes. I know that this point right here is included in that line of symmetry. So I just look at the x value, and I have to write x equals 2. And I would write that value, which is 4. You have to write this part right here. You have to write this part. Because this is officially a line. Yes, it's not a function, but it's a line. And when you write a line, like, for example, y equals 2x, we know that we have to have an equation, right? But what if I wanted to write y equals 2? Wouldn't that just make it like a left and right line? Going like so? So I do have to write this y equals 2. If I just write 2, I have no idea what you're talking about. I don't know if this is, what, like $2 that you had in your pocket, or you have 2 ears and whatever. Do you have 2 hands? I don't know. So it's important that you write x is equal to 4 when you're talking about a line that goes up and down. Let's look at this one right here. A little bit more complicated, right? Because there's 2 things that's going on, if you noticed. We have y equals absolute value of x minus 2 plus 1. So it looked like from our parent function, it moved up and to the right. So remember that in our domain, it doesn't matter how much to the left and how much to the right that we move our graph, it'll still be touching all possible x values. Like, you're allowed to have anything to be equal to x. Like, x can be like negative 42. The graph will still work. So I can write that as negative infinity to infinity. Most of the time it will always be, most of the time it won't always, but most of the time it will be this, all real numbers, because I just stated if I move it to the left and I move it to the right, will that affect what my possible x values are going to be? No. But moving it up and down definitely changes the range, because I didn't have all real numbers to start with whenever I'm talking about my parent function or my black graph right here. So we're talking about the red graph, of course. The lowest point that you can have on this graph would be 1. Nice. So 1. But you see how like this graph is going upwards as much as it can, and this part is also going upwards, right here. It's going upwards like so. So it can continuously go upwards. So that means that my largest point on my range would be infinity. So yes, changing how high your graph is compared does change your range. Your intercepts, what's weird about this graph right here? Do you notice that, well, do you know if you have intercepts? Yeah? Oh, I noticed that I have this intercept right here. 0, 3, which I just saw momentarily that I can't get highlighted. Oh, there it is, 0, 3. So that's the y-axis, so the y-intercept is 0, 3. But what about my x-intercept? Do I ever touch my x-intercept? Or my x-axis, sorry? No, I don't. I don't ever go low enough to get my x-intercept on this graph. As in, it's so close, but it's not touching, so it is not an x-intercept. So I would write x-intercept, none available, or not applicable. And this line of symmetry, we think about where can it fold, and where would how would we write the crease of like that, or how would we write like a function or like an equation to show that the crease is here. So the crease, if I folded this, would be on the vertex, which is the point that where it switches from going negative and going positive. That point right here is 2, 1. So all I have to do is really look at the x value. I have to look at this 2 and write it as an equation. X is equal to 2. And that would be my line of symmetry. Remember that a line of symmetry is a line, as in that equation has to be linear. As in this graph is linear technically because it's not bending or curving, and it has 2 infinite directions, going to the positive direction and the negative direction. Finding the minimum and maximum of an absolute value function. So the directions say, graph the following absolute value functions in your calculator and analyze the maximum and minimum of the given intervals. So the maximum minimum, these are y values. These are y values. And this right here, these are both x values. So first things first, let's try to graph this. So bye-bye. X, or absolute value of x minus 3 minus 1. And they're saying look between 4 and 7. So 4 is here, and 7 is here. I'll scroll a little bit more. There we go. 4 is here, and 7 is here. And they're saying which one's the smallest? What's the smallest y value between those two? And what is the biggest value between those two? So the smallest, which is minimum, would be right here. Because my graph is the lowest here between 4 and 7 equal to x. So my lowest value is 0. Or you can write it as 4, 0. Doesn't matter. I like this way more. but my maximum is 3, or it is 7, 3. So I can write 3 or 7, 3. Nice. Pretty simple. Really, the idea behind this is that you understand that like maximum and minimum are y values, and your your bracket, like your interval, these are x values. So I want to give you guys time to pause the video and try part B, and I'm gonna give you guys 5 seconds to do so, and I'm gonna solve it in 5 seconds. 5, 4, 3, 2, 1. Welcome back if you paused it, and if not, whatever. You got it. Well, you're gonna have to get it regardless. You're responsible for this information. So let's graph this right here. So I'm gonna erase this. Negative absolute value of x plus 1. And I'm talking about the points -2 to 3. So -2 is here, 3 is here. So these are x values. And these are, both of these are y values. So my smallest point on my graph for my y is it, oh, -2, so it's -2, 1, and it's 3, 2, or -2. So -2 is smaller than -1, so -2 would be my answer for my minimum. And that is also written as 3, -2. My maximum, which is the greatest value between these two values, between -2 being x and 3 being x, I can see that the greatest value, as you know, like when I go all the way up to the point of the mountain, the tip top of the mountain is the highest point, that would be +1. But the x value isn't one of these things. That's fine. We know that this is between -2 and 3, including those numbers because we're using brackets. So it doesn't have to be one of those two numbers. It just has to be between them or equal to them. So 1, the x value would be 0. So I can write this as 0, 1. Nice. Pretty simple. The last thing for today, we're going to be talking about interpreting attributes of an absolute value function in a word problem. This is a real world solution or situation. A ride at an amusement park carries passengers along the vertical tower to give them a view of their surrounding. During the test run, a park employee records the height of the ride for 10 seconds. For the function f of x is equal to absolute value of x minus 5 plus 4.8 models the height. So we're saying that height is y. Y is equal to height of the ride and in meters after x seconds. So this is meters. They told us the units. X is time, which is in seconds. Graph the function on your calculator to interpret the domain, range, intercepts, symmetry, maximum, minimum. So we've done all this. Really, what's challenging us here is, what do I do in this equation? And let's think about it. If I'm talking about like, I'm riding this ride for 10 seconds. So I'm starting from 0 seconds when I get on that ride to 10 seconds. There's no way, like, you are not Thanos. You do not have the time stone. You cannot go backwards in time. So when I graph this function, I'm going to rewrite this. Oh, what the? Get out of here. Absolute value of x minus 5 plus 4.8. So, oh, here's my graph right here. So I'm saying from 0 seconds to 10 seconds, as in that's my interval. Because you can't start recording the graph from -5 seconds. You can't go backwards in time. So our interval notation is 0 to 10 seconds because he wrote it for 10 seconds. So does that mean that he wrote it like 9 seconds deep? Yes. He was on the ride for 10 seconds, so you have to include all of those x values. So he's asking you for the domain, the range, intercept, symmetry, maximum, and minimum. Let's start with the domain because the domain is always free. If I know that I rode my thing for 10 seconds, what are the possible times that he was on that ride for 10 seconds? Isn't that really 10 seconds because he rode that ride for 10 seconds? So I can write that as 0, 10 as an interval notation because we know that he rode the ride for 10 seconds, not any longer, or he didn't record any longer. But what about the range? How high and how low did he go? So he was as high as here, 0, 9.8, right, where he started. He went down the ride in 10 seconds to 4.8, and in the other 5 seconds, he went back up to 9.8. 9.8. So my biggest point was 9.8. My smallest point is right here, which is 4.8. So I can write that as an interval notation. 4.8 as my smallest, 9.8 as my largest or my highest value that I can have on this graph between 0 seconds to 10 seconds. My intercepts, I have an intercept right here. I have an intercept right here, which is 0, 9.8, or y equals 9, not y equals, y intercept is 9.8 or 0, 9.8. But what about my x-axis or my x-intercept? Do I ever touch my x-axis? No. So I don't have any x-intercepts. So I'm going to just not write it. I'm not going to even mention it. But if you have anxiety, then you can just write no x-intercept. Just in case you're like, Mr. Hong might not know that I just didn't answer the question because I knew that there was no intercept. That's fair. So you can write that down. The axis of symmetry, we always look at the vertex for absolute values, and we just copy this x value and we write it as an equation. So x is equal to 5 because my vertex is 5, 4.8. So I just take this x value and I just write it as an equation of a line that goes up and down, which is x equals 2. So you do need to write this whole thing. You need every single part of this box for you to answer the line of symmetry correctly. If you write 5, it's all wrong. I don't know if you're talking about $5, you have 5 fingers, you have 5 toes. I don't know. You have to tell me this, all of this. So when we're talking about maximum and minimum, we really already did the work. And the work for both of these are here. Because isn't my range talking about my y? My maximum and minimum, they're talking about my y's too. And didn't I already say that this is my smallest and this is my largest? Which I'll write in different colors right here. This is like my smallest, which is my smallest. And this nice creamy blue color is my largest, and this is my largest. Yeah. So really I can just write 9.8 and 4.8 as my maximum and minimum. I can also write it as 0, 9.8, and I can write this as 5, 4.8, because I know in my graph, 0, 9.8 is my is where 9.8 exists. I know that 4.8 is where it exists. But if I really wanted to be specific, is there any other opportunity within those 10 seconds that you get 9.8 as your height? Yes, that's true. And it's actually right here. There we go. There we go, right here. I also get 10 comma 9.8. So I have to, if I write it as an ordered pair, I have to write both. Because both of these have the maximum value between the interval of 0 seconds to 10 seconds. So in this lesson, we pretty much learned the attributes of a function. Yes, we don't understand like what controls what, or like I don't understand how you can move from like left to right or up and down. That's what we're going to be learning about in 2.4 to conclude our lecture for Unit 2. But we did learn how to identify key attributes of a function, even if we don't understand like how to write an equation to make it move left or make it move up. We also learned how to write the maximum minimum and kind of like going over like our intervals of, you know, oh, these x values, tell me the maximum minimum of these. We kind of like went over that. Um, but that pretty much concludes 2.3. And I hope you have a good one. I'll see you at 2.4. Later, guys.